Phan. So I'm a staff scientist at NCBI. I'm in charge of a couple of variation resources here, mainly dbSNP and dbVar. A lot of you probably heard about dbSNP, and then also, so dbVar is just our sister, so dbSNP is just for small structural variations, and then dbVar is our sister database of large structural variations. So today I'll just be going to give a very quick overview of some of the resources we have that integrate some of this data, and then if you want, I could follow up with additional, if you have questions later, or do you want additional webinars or seminars on any of the resources I mentioned today, I'll be happy to do that. Okay. So, so dbSNP, here's a quick overview. So we have, it's been in existence for almost 20 years now, so we've been collecting a lot of different data from a lot of big thousands of submitters over the years. And so for each variant we receive, we'll assign an SS number, which is called a submitted SNP number. And currently dbSNP have almost 2 billion of these records. And so some of those, of course, may be redundant across submitters. So then what we do is we create what's called a non-redundant data set, or the reference SNPs. There's an RS, and those so that reduced the data set down to about a third. So now there's currently almost over 500 million of RS numbers. So that means that on average, on the genome, you have a variant every 5 base pair. And then, so what we do is, in addition to normalizing the variants, we also map it to the latest assembly. So in this case, we map it to 037, 38. And so the RSS number is very important because if you typically see them exchange, they're very important for data exchange, for aggregating annotation over, and for citing and publications. So for instance, and then we also, it's created a non-redundant data set we can annotate on the RefSeq, what we call RefSeq sequence, that includes mRNA, protein. So this just gives you some idea of all the number of genes we annotate across the genomes, and then these are the number of RS numbers for each different assembly version. So each assembly version will have a different sort of annotation set that is involved with it, so that the number may be slightly different. And then in addition to the variant, dbSNP also collect frequencies from various submitters, and so these are some of essentially some of the larger submitters we have. A lot of you may have know about Exact and Found Genomes and Nomad and GoSP, but TopMed, I think a lot of people are starting to hear about now, but dbSNP actually has this data for over a year now. And so, and the other thing about dbSNP, you have to realize that it's kind of a misnomer. Well, it started as for common polymorphism, but actually now, if you look at most of our data, it's actually rare. So you look here, it's like about 80% of our data is actually the rare variants. So it's a catalog of all. You can think of it as a catalog of all small variations, including somatics, normal polymorphisms, common and rare. Okay. And so this is what our dbSNP web page look like. I'll just get out of this quick, and then I'll show you live. You still see my screen? Sorry, I have to reshare it. Actually, let me see how I do that. I have to reshare my screen, I think. Okay. All right. Can you see the web page now?
Yes. Yep.
Okay.
There. Thanks.
So anyway, so what we have is we call it a dbSNP build, and we typically done quarterly, so that every time we get new either submissions, new assembly update, or new RefSeq, like mRNA or protein annotation on the genome get updated, we do a new build, and then of course the context and the interpretation can change, right? Let me just move this up. This is our new design web page, and you can switch back to. A lot of you may have seen our old web page, but essentially it aggregate all the information knowing about the variant over in there. So it includes the clinical system from ClinVar, there's different tabs here that shows, for instance, this is for the, I believe this is a variant for sickle cell anemia. So show that, and then there's also frequency distribution for all the different projects, and then give you some of the evidence or this different submitted to provide the different SS number for it, and also there's also publication on it, and then you can kind of for this variant, there's like 99 publications, so there's very rich information on it. And then in addition, there's a browser. I'm a little busy, but there's different tracks on there, and I'll go into a little bit. So all these sequence viewer browser are pretty much the same across NCBI, and I'll go over that a little bit in detail a little bit later. But anyway, so this is our website. So right now we're currently testing this site out, and it will go live. It's live right now, but it will fully switch over in about a month. This will be our default page, and this is our old page, what it looks like. So that's it. Okay. So we would love to have feedback on what you feel about that page. Okay. Any questions so far?
Yeah, that looks really cool. So I have a quick question about publications. Presumably you're just pulling this in via PubMed, is that right?
Okay, I can go over that a little bit. So this is both from, so we have either the submitters submit the PMID, the publication associated with that variant. Let's say they've been, or it's from assertion from ClinVar. But we also do what we, so I'll switch again, sorry. Let me just stop that. I'll switch back to my slides. Okay. Sorry about that. Okay, let me see here. Here's the slide. That's odd. Oh, it's hidden, sorry. Let me hide that. Okay, there we go. I had it hidden for a reason. Okay, so we also do text mining in terms of like when an RS number gets cited in a publication. So this just shows you a graph of like the number of publication per year and the number of RS that gets cited. And this just shows the growth over the years. So that's on average is about 4,000 or 3,000 publications a year, and then there's about some 20,000 some RS gets cited. So we do text mine and extract that out, and then that gets linked to our record, because these are essentially these articles explicitly citing that RS numbers. And so there's a huge volume of literature for a lot of these variants. In total, I think that's about 45,000 publications over several thousand different types of journals, and then there's about over a little 120 or 200,000 RS. So on average, there's only a few variants cited per publication. And what we have is, and then we also collaborate with, so this is a new resource that you may not be familiar with, but we collaborate with our computation group here, our text mining group. So they've gone through and also done a little text mining of the literature in terms of pulling out, what is the disease described in this article, what is the chemicals that describe in them, and other concepts like genes and variant and other things too. So here's the variant, like all the RS is cited per se. So you can search, and it also, what it does, it normalizes all the different ways the variant is described. You could describe a variant using the protein coordinates, or you could say, like it's an alanine change to free text, right? So this does all of that. If you see here, there's different way that this mutation has been described, but it's all been normalized in this particular variant. And so you can search like, put CFH and then R to 120C per se. So this is the normal, the natural language, I guess, the way people does these damn things. So this is our attempt to do the whole literature search, text mining, identify anything that we know about the variants. And of course you can also, anyway, so I can do that's LitVar. So and then
can I ask a quick question about LitVar too? It's really, that looks really cool. I guess do you know when they do their text mining, are they looking at the entire article or supplemental information or just at the abstract?
We do full scan, text scan.
Fantastic.
And then so this actually pull out something like, I think, like 400,000 variants,
Wow.
and that so like I said, because a lot of the paper don't cite the RS number, but they may use something like describe it as a some amino acid change or nucleotide change, but we can our text mining can normalize to a particular RS number. So then now you can then link it to ClinVar and then know that okay, this variant is pathogenic, and then you can also go to dbSNP and find frequency data and sort of aggregate all this information together, right?
Yeah, that's cool.
Okay, so that's basically a kind of an overview of dbSNP. If you have any question, I can answer that, and otherwise I'll move it on to dbVar. So a sister database for large structure variation is dbVar, and this catalog all the large structure variation, right, or like translocation, copy number, large chromosome rearrangement, stuff like that. So this is here an example of some of the samples from the genomes catalog in there. So this shows you that there's a deletion in here, right? So these are the sequence read from 2 genome samples. This individual has the sequence here that's represented in the reference, whereas this individual is missing the read, so that they have a deletion of this thing, right? Of course, structural variation is also in ClinVar, and what dbSNP and dbVar does is we instantiate the variant and ClinVar, and we do all the remapping and all the annotation on the gene, something like that. But we connect our connection to ClinVar is that ClinVar store all the clinical assertion, all the evidence for that. And they just show you a breakdown of all the different variants by sizes that are in ClinVar. So ClinVar now has something like total of like 400,000 variants, although those are, there's 70,000 are pathogenic that are less than 50, so on like that. Okay, and then I can show you our variation viewer, which you may not be familiar with. Sorry, stop that again. All right, I think this is it. Okay, that's a page, and here again, this is LitVar. You can search by it's a full website. You can search by just normal variant description, or any type of free variant description, HVS, RS numbers, something like that. And then, okay, so this is our web page. So our other tool is a variation viewer. So if you go to our new web page and you go down here, you can see the detail of this variant on here. So popular is that if you're not familiar with this. Actually, I have one loaded already. Let me just, it might be slow, but depending on some region, how big a span it is, it may take a while to load it here. Here I got one already loaded, okay. What it does is it allows you to, first off, we have annotation both here 637, so you can toggle between that. And then you can search by RS numbers, and there's other different search. Let me see, let's just Google it. All right, so here you can search by chromosome locations, genes, and there's many other different ways you can search, okay, or phenotype. And anyway, so here's the sequence viewer, and what's unique about this and other sequence viewers is that we have this exon navigator. So if you want to go to exon 5 or whatever, 1, and so on like that. That allows you to navigate between exons. Yeah. And you can toggle between the genes and then the different mRNA transcript, because there may be multiple transcript versions for that same gene, because if there's different haplotype perhaps. Okay. focus on that RS numbers. So, and then the other thing you can do with this is you can upload your own tracks. I'm not going to do it right now, but you can load your own VCF, bed file, your own annotation to see alongside what the NCBI has. Or what you can do is, we also have other additional, so on the sequence view here, we have integrated all the data from clinvar, dbVar. So this showed all the variants in large variant clinvar. And then so I'm just going to shut it off now just to reduce the noise a little bit. And likewise, we have a small variation for clinvar, very small variation. Here you can look here, this one, you can mouse over it. So the color indicates the pathogenicity. So this one's pathogenic, purple, and there's other different color, lighter colors. And of course, and then here's the variant we're looking at, and let's correlate with that. And down here, you can see this is the variant in detail. And about some of the annotation on it, and then the frequency. That's from down genome. And on the left here, there's additional filtering thing. You can filter by variant type, record from data sources. Is this variant in clinvar or not? And this shows that within this region, there's two in clinvar, one here, one here. Again, you can mouse over, get the details, and you can click on it to go to clinvar. And then you can also filter by frequency. Right now, we only just have one down genome exact on this one, or if it has publication on, or by consequences, if it's a nonsense and so on like that. The other thing that is kind of useful is that these tracks, you can also add what other track NCBI has. So, in instance, here, let's go to variation. We already have the clinvar sort variation track. Well, let's go. If you want to add the db gap, sort of like what Mike was talking about before, there's an NIH GWAS catalog tracks. You can add that. It'll take a while to load. So this provides sort of integrated view of a lot of data sources, not just from the assembly, RefSeq, clinvar, dbGap, and even PubMed. So here's the GWAS track. It shows you the p-values that observed and scatter plot in this region. And here you can mouse over to use all the different studies that has, so there's some macular degenerations, and there's, it looks like there's, I'm sorry. Yeah, so it looks like there's 4 studies. Let's see. Yeah. So there's different p-values on that same variant. Okay. So that's basically it. Just a quick overview. I think my time is up. So we would love to hear from you, understand what your workflow is, what problems you're trying to solve daily, and can we align or make our tool better to improve what your workflow and better to help you interpret a variant or to find information and that kind of thing. So that would be very, for us, it'd be very nice if we can get that information or feedback from you. Okay, any questions?
Sure. Any questions, anybody? Did you said that this is linked to literature as well, right? If you find a variant on here that you can then go to any available literature on that variant?
Yeah, most of our web pages, for instance here, you can go from our web, you can click on this and go to literature. And actually there's, go ahead. And actually within PubMed, you can search for like an RS number, let's say. There should be a sensor on that knows that you're talking about an RS number. So there it's it's a best mass, blah blah blah. Then there's all the literature on it. Like I said, our new tool is a litvar that allows you to. What it does, it takes all this information, kind of synthesize a little bit or aggregate it down to like what are the key concepts are. Because a lot of times, like some of these RS may have hundreds of publications, when you maybe you're only interested in a particular disease or gene or something like that. So
right. I think that's definitely one of our challenges is just finding all available literature in a certain variant. So I actually haven't tried LitVar for a while, so I'm looking forward to trying that again. I think I first tried it when it was first being developed, but yeah, definitely look forward to trying that again.
Right. Yeah, so yeah, if you're just interested in a particular phenotype of some of the disease or certain chemicals, something like that, and then it's going to help you narrow down your searches.
Yeah.
But we also looking at improving this. So this is sort of still actually in prototype or beta version. So.
Okay. So is this publicly available though? This version?
Yeah.
Okay.
I can send you the links, and then if you can share it with the group later.
Okay.
Yeah,
Sure.
it's
Yeah.
just, like I said, it's under CBD research, and it's still a demo. But
okay.
yeah,